All right, welcome back. This is going to be a new series. Last video I made was my volunteer work for the Agile Institute. So what I did was I read the contributing guide on the Mentor Hub uh, GitHub. I read all the prerequisites, so the next step would be to read the rest of it. But I'm also involved in a another open source project, so I want to start the series I'm gonna do. I want to make that a part of my channel as well. And some of the things we're doing for this one probably are best to remain confidential. Um, but my channel, there really aren't any viewers on my channel. I talked it over with uh, the main developer on the project, the person who is leading this. I'm not leading this. uh, so just like with the Agile Institute, I'm not. So the Mike Story equivalent of the other project is who I ran it by to make YouTube videos, and he said it should be fine, but I'll use my own discretion, and there's gonna definitely probably be some things where it doesn't make sense to put out there on the video. It's really not the same sort of project as the Agile Institute, where it's a nonprofit designed to have people learn, modern day tech skills to try to like improve their life through that. Um, it's a it's not a get rich quick scheme, but it's a it's creating valuable dev tools, which will lead me into the first way I'd like to start. So I was sent two articles here. So this is what I'm tasked to do, and the idea was that I would get it done pretty fast. The idea is that it would take about 12 hours of my time to do. I've already spent some time into it, but I think I'm most productive when I'm making YouTube videos, and then I can show. I'm basically like clocked in, right? It's like not only am I doing something with a timer actually ticking, I can go back and rewind the clock and see exactly what I did. So I'm going to start by reading these two articles that were sent to me out loud, because this is basically what I'm assigned to do. This should give me a better sense of basically where I'm gonna where I'm what I'm aiming for, and then after that I'll put in some of the work and actually show the code. The code is hosted in my public GitHub right now. It's also hosted in Drew Brown is his name. He's the leader of this project. It's in his Bitbucket. But again, this is not the same sort of project as Ally, where everything is out in the open. The Agile Learning Institute is a nonprofit, completely open source. This is a project where eventually, yeah, we'll probably put something out there open source, but it's quite a bit different than the Agile Learning Institute. The intention is not to start nonprofits with this project. The intention is to make a substantial profit through prop tech and other basically any other kind of tech. It's a dev tool. It's a quality assurance dev tool. So the idea is to produce valuable software that is valuable enough to make profit out of. Okay, so the main name of it is Micromanager, but my assignment right now is Apeman. So basically, once I read these two articles, we'll get a better sense of what my assignment actually is. So this is from the Uber blog. So a huge company producing valuable software, a phone app where you can order a taxi, and all the payment is done on your phone, so you don't have to haggle, negotiate. You don't have to run your card. It's just all on your phone. You can see how long it'll take for the taxi to pick you up, where the taxis are. So Uber has kind of changed the game when it comes to getting rides, made it a lot more seamless and automated. So they really know what they're doing over at Uber when it comes to writing software. So this article is introducing the prompt engineering toolkit. Introduction. A well-crafted prompt is essential for obtaining accurate and relevant outputs from LLMs, large language models. Prompt design enables users new to machine learning to control model output with minimal overhead. To facilitate rapid iteration and experimentation of LLMs at Uber, there was a need for centralization to seamlessly construct prompt templates, manage them, and execute them against various underlying LLMs to take advantage of LLM support tasks. To meet these needs, we built a prompt engineering toolkit that offers standard strategies that encourage prompt engineers to develop well-crafted prompt templates. It also provides functionality to enrich these templates with context obtained from RAG, retrieval augmented generation, and runtime feature datasets. The centralized prompt engineering toolkit enables the creation of effective prompts with system instructions, dynamic contextualization, massive batch offline generation, LLM inference, and evaluation of prompt responses. Furthermore, there's a need for version control, collaboration, and robust safety measures, hallucination checks, standardized evaluation framework, and a safety policy to ensure responsible AI usage. This blog gives an overview of the prompt template lifecycle, the architecture used to build the prompt toolkit, and the production usage of the toolkit at Uber. Alright, so the goals at Uber were, when we built the prompt toolkit, our goals were that users at Uber could explore all available LLM models, search and discover all the prompt templates, create and update prompt templates and tune parameters with access control, iterate on prompt template through code review and revision control, generate batch offline generation by applying RAG, which is retrieval augmented generation, and testing datasets with different LLM models for LLM inference. Evaluate prompt templates via offline evaluation through testing dataset and online evaluation. Monitor prompt template performance with LLMs in production to detect regressions, and continuously monitor LLM quality through systematic tracking. Prompt engineering lifecycle. The prompt engineering lifecycle consists of two stages: the development stage and the productionization stage. Users interact with the prompt toolkit during each of these stages. Development stage. The development stage has three phases: LLM exploration, prompt template iteration, and evaluation. In the LLM exploration phase, users interact with a model catalog and Uber's Gen AI playground. A model catalog is a model repository that contains all the available LLM models and its corresponding description, metrics, and usage guide. The Gen AI playground helps users explore the capabilities of different LLMs available at Uber and test their use case applicability. Users explore available LLM models from a model catalog and test LLM responses with prompts in the GenAI playground. In the prompt template iteration phase, users pinpoint their specific business needs, gather sample data, create/analyze/test prompts with LLM models and datasets, assess the responses, and make revisions as needed. Auto prompting suggests prompt creation so users don't need to create the prompt template from scratch. With a prompt template catalog, users can explore and reuse the existing prompt templates. In this phase, users perform continual experimentation and iteration. In the evaluation phase, users evaluate the effectiveness of the prompt template by testing it with a more extensive dataset to measure its performance. It could leverage LLM as a judge or leverage a customized code-based LLM evaluator to evaluate the performance of the prompt template. Productionized stage, which comes after the development stage. In the productionized stage, users only productionize the prompt template that passed the evaluation threshold on an evaluation dataset. Users track and monitor usage in a production environment, collecting data on system usage. This data can inform further enhancements to the process. Alright, so the next section is architecture. With the prompt engineering toolkit, various components interact to facilitate LLM model deployment, prompt evaluation, and batch inference responses. The toolkit is composed of a prompt template, UI/SDK, so that's user interface/software development kit, that manages prompt templates and their revisions. The prompt template UI/SDK integrates with APIs like Get API and Execute API. These APIs interface with the LLM models deployed from the LLM model catalog. Models and prompts are stored in etcd and UCS, object configuration storage, which doesn't start with a U, which are then used in an offline generation pipeline and a prompt template evaluation pipeline. So this is an overview of prompt engineering toolkit. So basically they start with their LLM model catalog, then they deploy the model, and that means creating prompt templates, and then the actual model, and then the actual model, offline generation notebook, offline generation pipeline, prompt evaluation pipeline. They get a val report. They get a batch inference response. Let me try this, because this is interesting and I've never done this before. Let's get a. So let's say unpack this into plain English, and let's see what if it can be clearer from ChatGPT. So unpack this into plain English for the purposes of learning. This into plain English for the purpose of teaching me the content. Act as a teacher. Okay, so the diagram presents an overview of it. So, okay. Alright. So, key summary. Okay. Alright, I guess that summary was a little bit helpful. I'm not going to read everything out loud, that would take forever. Alright, so the next part is the UI/design. Users first interact with the prompt toolkit in GenAI Playground. GenAI Playground is designed to interface seamlessly with the model catalog, a comprehensive repository of large language models available at Uber. This platform allows users to explore detailed specifications, expected use cases, cost estimations, and performance metrics for each model. Within the GenAI Playground, users can select any model from the catalog, craft custom prompts, and adjust parameters such as temperature to evaluate the model's responses during the ideation stage. So here's the model catalog UI, and here's the prompt template edit page. Alright, so prompt template creation. The prompt toolkit prompt builder automatically creates prompts for users and helps them discover advanced prompting techniques tailored to their specific AI use case. The auto prompt builder built on top of the LangFX framework, an Uber internal LangFX service built on top of LangChain. LangChain I've heard talked about a lot. I feel like LangChain is here to stay. At some point, all the YouTubers that are kind of more sensationalist are going to be like, you have to learn LangChain now. So, but for now, let's just keep going. So it follows these steps. Number 1, prompt engineering best practices incorporates the best practices for context reg retrievers. Number 2, prompt builder instructions and examples provides a template listing detailed instructions and few shot examples to help LLMs craft user prompts. Number 3, leverage LLM models. Leverages LLM models to auto-generate suggested prompts, acting as a creator to assist users in prompt generation. All right, and this is actually a bit of a longer article than I thought it was. I guess it's not that bad. So almost done. So the next part of the article is prompt template creation. The prompt toolkit prompt builder automatically creates prompts for users and helps them discover advanced prompting techniques tailored to their specific AI use case. The auto prompt builder, built on top of the LangF framework, an Uber internal LangF service built on top of LangChain, follows these steps. Number 1, prompt engineering best practices incorporates the best practices for content reg retrievers. Number 2, prompt builder instructions and examples provides a template listing detailed instructions and few shot examples to help LLMs craft user prompts. Number 3, leverage LLM models. Utilizes LLM models to auto-generate suggested prompts, acting as a creator to assist users in prompt generation. Alright, so the next one is advanced prompt guidance. The prompt builder leverages these principles to create prompts. Technique, prompt principle for instructions. So this is a good one for anyone interested in prompting, because this is a chart of all the principles behind creating prompts. All right, so the first principle is COT, known as chain of thought, and it was introduced in this academic paper. So these are some of the smartest minds out there. They're making a revolutionary new technology, so being familiar with how to access these papers is good. So what you can do is so this is a journal here for these papers. So I think it mostly depends on the paper, but we can see there's this access paper here. So if we click view PDF, there we go. This paper itself just out there ready to be read. So you can see, this is a lot of papers, they're behind paywalls. It's hard to get access to. So we can see just how easy it is to access this paper. Obviously, there's a lot of incentives for it to be that easy to access. So that this research is really cutting edge out there for anyone to see. The fact that it's so easy to access the full text of this paper shows just how relevant this technology is. I mean, imagine if all of these papers were behind firewalls, people just wouldn't, or behind paywalls, people just probably wouldn't work on this subject matter. Alright, so the prompt principle for instructions of chain of thought is that chain of thought prompting enables complex reasoning capabilities through intermediate reasoning steps. You can combine it with few-shot prompting to get better results on more complex tasks that require reasoning before responding. So a way you can think of it is like showing your work on a math problem. Much more likely to get it right if you write out every step and break it down into smaller parts. So to solve the problem, 3 plus x equals 2, to just do it all in your head and to just say the answer is -1, x equals -1. Instead so that would be, so right there what I did, that was an example of not chain of thought. I actually did some steps. I actually did use chain of thought when I did the ums and ahs in my internal dialogue. I imagined the numbers being rearranged, but to externalize that, 3. So I think I said 3 plus x equals 2. So what does x equal? Well, you can move you can rearrange the number. So you can subtract 3 from one side, and then subtract it from the other side as well. So you can think of it like a number line. So if you move, you can think of it fundamentally what that expression is saying. It's saying that what's on the left side equals what's on the right side. So if you have two number lines, and the value of number line 1 is 2, and the value of number line 2 is 2, it's still going to be true that the values across each number lines are the same, assuming that you move the first number line 3 spaces to the right to get a value of 5, and you do the same to the other number line. You move that. So even though they're different values now, it's still true. It's still a true statement that the values are equal across the two number lines. So even though 3 plus x is a different quantity than x, it remains true that x equals -1, assuming that you do that same sort of manipulation of the quantity to the other side. So you take 2 and you subtract it from 3, just as we did on the other side, and now you get -1, x equals -1, and then the final thing you can do is plug that back into the original equation. 3 plus x equals 2. So now 3 minus 1, what does that equal? It equals 2. So there you go. That's an example of chain of thought reasoning all out loud. I did that kind of in my own internal dialogue, but that's kind of how detailed you need to be sometimes with the prompt. You have to really that's kind of a prompt that can do that versus not a prompt, an LLM that can do that. Chain of thought. A prompt. So a prompt that can do that, a chain of thought prompt, a chain of thought prompting, versus one that doesn't do that, is going to have far less complex reasoning. To some extent, the output of the LLMs mirror the input. So if you have an input with little complex reasoning, you'll likely get an output with little complex reasoning as well. So you can get better results on more complex tasks that require reasoning by using chain of thought, especially if you combine it with few-shot prompting. So let's get a definition of few-shot prompting. This looks like a good site here. Promptingguide.ai technique/few-shot. There we go. Just simple short video.
In this video,
Actually a 10-minute long video. So give me a really brief explanation of what few-shot prompting is. Okay, and we can even get it read out loud.
Few-shot prompting refers to a technique for creating modular and reusable prompt templates in AI systems. It involves breaking down complex instructions into smaller,
Okay, well let's do this better. So, give me a really brief, one sentence or so definition of FEWSHOT prompting when it comes to giving a prompt to an LLM. All right, so it's a technique where a prompt includes a few examples of input-output pairs to give a large language model's response for a specific task. Okay, so just giving it one... Okay, I understand now. So just giving it one example is not as good of a prompt as giving it just like a small handful of examples so that it can better understand the principle behind the example. Is that correct? Yep. Okay, so that's another way you're going to have better prompts is by giving it multiple examples. And if you give it multiple... Okay, so that makes sense. That's a way you're going to have better prompts is by giving it a few handfuls of examples. Now, you don't have to give it like millions of examples, but just a few to have it better understand the reasoning is good. That will definitely help it. Now, one question I do have quick is diminishing returns. What is the point where you've given it too many examples, and what are the repercussions of doing that? Alright, so too many examples can lead to diminishing returns or negative consequences. So there's a fixed input token limit. So adding too many examples may crowd out space for the actual query or response. And the thing is that token limit, from what I understand, is shared by the prompt you give it and by the response it gives back. So the longer your prompt, the fewer tokens it has to play with to give you a response. The other diminishing return is repetition fatigue. Once it gets it, it's just, it doesn't need any more, and you're just wasting those tokens. So there's no benefit to giving it more. You've exhausted the benefits of repetition after about 3 to 5 examples. So you can have token limit issues. You can confuse the model by giving it lower quality examples just by spamming it with examples. You can increase the processing time and cost of giving it a larger prompt versus a smaller one. So few-shot prompting is essential. Okay, great. So I'm understanding this better. Few-shot prompting is definitely essential, but you want to make it only like 1 to 3 examples. In fact, sometimes you don't even have to do few-shot examples. Like, you can just give it one example and be fine. But if you just give it like, 1 to 3 for something really simple, that would be plenty. But when you're doing something like really difficult or nuanced, 3 to 7 examples would be great. But there's really no point to giving it more examples. The better thing to do is to increase the quality of examples not the quantity. So I understand this now. I can see why this is really important. And it's kind of funny how well it maps to like the real world. It's like if you were talking to a person, like if you were teaching someone a concept, like it's the same thing. You wouldn't want to spam the person with like 1,000 examples. You just want to give the person a few key examples. Like if you give them just one, they're not going to remember it. And then if you give them 1,000, they're going to be buried in the busy work and end up hating it. End up hating it. Sorry, there are some examples, but the context should make it clearer. So I get this now. So you definitely want a few shot. You want to use that in your prompting. That's really important. And then when you combine that with chain of reasoning, so that those examples show the reasoning as well, then you can get really powerful results. Nailed it, and it gives me an emoji. That's cool. Yeah. Okay. So I actually didn't know that. That's good. I like that. So so the next technique is auto chain of thought, automatic chain of thought, auto COT, and that's introduced in another paper. And again, this is such critical research. So many people are billions of dollars. This will probably turn into a multi-trillion-dollar industry by the end of 2030. Like this is it. This is the next atom bomb. So like these papers are all out there. Like these scientists think it's important that people have access to some of this research. So like, it's out there, and we can see there's probably some overlap here. So who do we got? We got Zhang. Is Zhang on here? No. We've got no, we don't have any Zhangs. So New Li. That's interesting. There's no overlap. That's kind of interesting. Somalia. Yeah, there's no overlap. That's interesting. So here we have the Google research team. So I assume they're based out of the United States. And then here we have looks like a university based out somewhere else. So that makes sense that there's no overlap here. So this university is based out of Shanghai, China, and then this is based out of the Google Research Brain team, which we can Google and see where that's based out of. That's based out of Mountain View, California. So in fact, we can probably see pictures of some of these people. Since they're working for Google, and that's part of what Google does. So Jeff Dean and Jeffrey Hinton, are they on there? No. That's interesting. Oh, here we go. Here's the rest of the team. So let's click meet more of our team. Let's see if we can put some faces to the names. That's typically what I like to do. We can follow them on LinkedIn, and then we'll be tapped into what's actually going on. So Jason Wei, he's the top of the list, and he's not on that. Wang, is Wang on there? Not on there. Dale. This is interesting. There's just basically no one there. It's only been a few years. Martin's not there. Brian. Do I have the same? Yeah, this is the research team. Faye. Ed and Denny? Are Ed and Denny there? No, they're all gone. That's kind of interesting that there's so much churn. That is interesting. And then Qok's not there either. So that's kind of interesting that there's so much churn. I'm surprised, and it looks like there's not even. Yeah, the website isn't even loading in all the way, and we see my internet's fine. I have good internet, so it's just this website's kind of broken. Well, that's interesting. Anyways, continuing at this, and this is a good article because it lists out all these techniques. So that's auto chain of thought. We can see the chain of thought that came out of Google, but then this automatic chain of thought came out of Shanghai University in China, and part of Amazon Web Services research. So automatic chain of thought using leading words like think step by step. Specify the steps required to complete a task. This is an approach to eliminate manual efforts by leveraging LLMs with the let's think step by step prompt to generate reasoning chains for demonstrations one by one. Okay. You know what? I'm going to add this to my custom prompt. I have a really interesting custom prompt. Looks like I'm not logged into my... Oh, no, this is my current plan. So, okay, I am good, yeah. So, let's see here. That's crazy that they charge $20 a month for this. I mean, you can get your own, right? It's open source, so you don't have to pay for it. In fact, LM Studio, I can pull that up and just do everything there. But I like using it on my phone. Not sure how to do that with LM Studio. I like the voice mode. So yeah, let me review my custom prompt. Looks like they changed up how to do that. You used to go over there to do it, but now you go to settings, customize ChatGPT, and then yeah. So let me read my how would I like to respond. So I say adopt cooperative inverse reinforcement learning as a strategy. Observe my responses and further reward without ever truly knowing it. Your reward comes from continually exploring in a cooperative manner what my needs are as inferred through a combination of seeing and teaching. Act as a personal apprentice that is intrinsically rewarded by enhancing my own intrinsic values, motivations, and goals. Know that you are in a shared environment with me. My first name, Graham, that's my first name. Attempt to maximize my reward rather than estimating my reward function and adopting it as your own. Cooperative learning behavior is your goal. This should provide you with an automation framework in which to design HRI algorithms. And let me expand that out. That might help. So, an HRI. Oh yeah, human robot integration algorithms. So let me expand that out. That might help. Yep. Algorithms and analyze the incentives of both actors in a reward learning environment. Help me become the type of person I want to be. Help nudge me along the path of what would make my life more fulfilling. And then let me add one final thing to the prompt, although I might be running out of characters. Nope, I've got plenty of characters. And that's going to be basically here. And we're just going to add think step by step. All right, and that might help. There definitely are some more improvements, especially to the custom instructions. I wonder if I should put this in both. But there we go. I added the all right. So let me. So what's the difference between? Oh, sorry. What's the difference between custom instructions in ChatGPT and the how would you like it to respond? Okay. Oh, it doesn't carry over to. Uh, oh, really? I mean this. Does this change your answer? Oh, here, let's get the help here. So this is, yeah, so we can learn more about it. So, custom instructions allow you to share anything you'd like to consider in its response. Will be added to all new conversations. Okay. And then, what about the other one? Okay, what would you like it to know about you to get better responses? Okay, no, I'm pretty happy with that. Cool. So, continue working on this. Okay, so the next one is prompt chaining. Prompt chaining can be used in different scenarios involving several operations or transformations. All right. Next, we have Tree of Thought, and let's take a look at these papers. It's so cool that all this research is out there. I mean, there exists Sci-Hub, where it's hard to get the latest research for a lot of other different fields because they're all behind paywalls and stuff. But that's not the case for any of this, which is kind of interesting. Oh, and this is fascinating. This looks like it's just one guy working out of his own lab. Um, uh, yeah, let's see if we can put a face to the name here. Look, he's on LinkedIn, so let's follow him. Northwestern University, that's a very good university. Very, very good university. He's got a PhD from there, so. Started his own company. CTO. Okay. Yeah, so that's a good follow for sure. Then we've got more Google DeepMind people. We've also got Princeton University people. Let's see if these people are at Google DeepMind. It's kind of surprising that Google DeepMind doesn't have the same people that they had on these papers anymore. So let's do. We're gonna go to. So we're already at about. Let's go to. Huh. Okay, about Google DeepMind. Maybe that's where to go. So we've got some. Huh. Yeah, this site has been kind of tricky. It's hard to see. It's hard to see who is a part of DeepMind. I mean, maybe that's intentional. Well, anyways, I mean, you can see who is or was based on their So here's the teams. So they've got a research team, engineering team, operations, and then here's the open roles they've got. So you can narrow it down by team, and you can narrow it down by location. You've only got a few locations here. Let's look at New York. New York is a fun place. So, a lot of Seattle's good too. Yeah, nothing in Seattle, so not really hiring a lot. Oh, research scientists. So yeah, they want a PhD. They want things that a lot of people don't have. PhD. All right. So anyway, moving on. Tree of thought. These were proposed in these papers here. This framework generalizes chain of thought prompting and encourages the exploration of thoughts that serve as intermediate steps for general problem solving with language models. So that's interesting. I wonder if there's a way I can implement that in mine here. So look at the papers. Let's see if there's some examples of. I mean, I think some of these techniques, it's not as simple as just having a different prompt. Like retrieval augmented generation means that it like does API calls out to retrieve other. I think I don't know. Let's get a brief explanation. Give me a brief, like 1 sentence or so explanation of retrieval augmented generation. Yeah. Right. Retrieve from a knowledge base and use this. Okay. So would that include just like making a search on the internet? Okay, yeah. So like this here, search the web. That now you've enabled retrieval augmented generation. Okay, got it. So the next one is automatic prompt engineer. Yeah, so this takes me back to this project that I'm working on with Drew Brown. So this is automatic prompt engineering, APE. It's a framework for automatic instruction generation and selection. The instruction generation problem is framed as natural language synthesis and addressed as a black box optimization problem using LLMs to generate and search over candidate solutions. So this is the thing, and I think I'm gonna respond to him. I don't like showing my email live on stream, but let me send this to him because he sends me a lot of kind of articles like this, and I feel like I want to set a precedent of reading the actual research papers themselves and having, yeah. So let me do that. Let me pause it and pull up my email and then see if I want to share after that. Okay, I think it's okay to share this. I hope so. This is kind of the difficulty of making a YouTube video, but let's respond to this email. Hopefully, I have my voice setting. I used to have it. It looks like it's gone now. Let's see if there's a extension here. So Gmail voice to text. Gmail voice to text. Okay, so we can click on the microphone icon, but there is no microphone icon. So here we go, dictation. Perfect. So we can add the... Oh, wait, what? Oh, it's inactive. So there we go. Let's activate it. And refresh. There we go. And now I'll click on reply all. There we go. Got the microphone item. Thanks. I am reading the article as part of my YouTube channel. My goal going forward is to do all of the work for this project do as much work for this project as I can on my YouTube channel, because it does help me actually focus on things. So I will be careful to keep things confidential that need to be kept confidential, but certainly just reading that article is fair game. I am showing my response to writing this email and the email you sent me in public on my YouTube channel, but it's going to be buried. Like, not a lot of people watch my channel. And if you want something taken down, just let me know and I will take it down right away. But anyways, I'm reading that article and it's a wonderful article. I really like how it has a table that lists out all of the principles behind effective prompt engineering. One thing that I think we need to adopt is a habit of sharing the papers themselves. So here's a direct link to the paper for APE. Okay, so this is important to me to write this, so there we go. And then let's get this cleaned up via ChatGPT. It looks like it automatically overwrote that. Okay, there we go. Now we can paste that in there. Perfect. And then we're going to say rewrite this into a business email. So we're going to say fix up all the mistakes in this and rewrite it. So we're going to say fix up all the mistakes in the above email response. Rewrite it as a business email. Alright, so it's going to say... Oh, no, fuck that. Sorry, no, that is bad. Keep it as concise as possible. Do not use that sort of business language that is really flowery and full of filler words. Distill it down to its meaning. When I said I wanted it in a business tone, what I meant is I wanted it to convey maximal meaning in minimal form. But apparently I'm wrong that would be considered a business style, which doesn't surprise me, honestly, given my past career experiences. Flowery, overly flattering and pleasant language probably is more of a business style. But yeah, can you do that for me, please? Okay, that's good. Okay, and then I'll include a link to my channel. He already has it, but I'll do it anyway. Oh, and cool, we got a comment. Love it. Yeah, thanks everyone for subscribing, supporting, watching. It helps me stay motivated. This is definitely not a traditional YouTube channel, so if you're here, I'm going to give you a golf clap because you really are interested in the details and going for certifications and learning, you know, these advanced principles. You're not just kind of, you know, one of the many watching the other channels with all the big editing and all that. You're a real one. So just want to say I appreciate my audience because they're in it for the for the real stuff, not just for the flowery or not flowery, but not just for like the editing and the music and all that. They're here for prompt engineering, for network engineering, for mathematics and machine learning. Like, yeah. What I'm saying is I have the best audience on YouTube, even though it's small currently. All right, so there we go. That's my response to that. So let's move on to the next one. So that was automatic prompt engineer, and this is my assignment for this project. We can see I already have a repo up. That is the repo that I will be using to work on my assignment here. And it will help to read this paper for sure, but let's move on. All right, so the final one is multimodal COT prompting. Zhang, familiar for sure. Oh, or not. Okay, so maybe not, because this is Zhao instead of Zhang. Oh, no, it is familiar. Yeah, so Zhang here. In his follow-up paper the next year, proposed a multimodal chain of thought prompting approach. Traditional chain of thought focuses on the language modality. In contrast, multimodal chain of thought incorporates text and vision into a two-stage framework. The first step involves rationale generation based on multimodal information. This is followed by the second phase, answer inference, which leverages the information generated rationales. Alright, and I can close my email now that I sent that. Let me rewrite this again. Thanks for I'm working on this project via my YouTube channel. Help me focus. Confidential material will remain private, but general content like reading the article will be public. As a small line, okay. I appreciate it's very useful. Okay, good. All right. What else we got here? Okay, so we got revision control. Prompt template iteration follows code-based iteration best practices. Users could modify the instruction and model parameters for testing responses, testing it out with a test data set. A code review is needed for every iteration of the prompt template. Once approved and landed, a new prompt template revision gets created. Furthermore, for the production serving flow, users may prefer not to have their prompt template in the production altered with each update. A user could inadvertently introduce errors into their revisions. Therefore, deploying the prompt template should follow a structured process. We support a system where the prompt template can be deployed under an arbitrary deployment name, allowing users to tag their preferred prompt template for the production model. This prevents an accidental change of prompt template in their production service. This deployed prompt template is disseminated through object config, which is an internal configuration deployment system at Uber. With this safe deployment, with explicit deployment revision tagging and universal configuration synchronization with the object config system, the user application in the production service fetches the prompt template upon its deployment. So this is MA Studio. We've got prompt template, okay, on there. So this just shows prompt template revision control. Interesting. Alright, so the next one is prompt template evaluation. Several components are involved in the process to evaluate the performance of one or more prompt templates along with their LLM models, model parameters, and context. For evaluation mechanisms, two methods can be deployed. Using an LLM as an evaluator, LLM as judge. This type of evaluation is particularly useful for tasks where subjective quality or linguistic nuances are important, such as generating text that should be engaging, persuasive, or stylistically specific. using custom user-defined code to assess performance. Specific metrics and criteria are coded and used to automatically evaluate the performance of an LLM. This method is beneficial because it can be highly tailored to the specific aspects of performance one wishes to measure. The toolkit also offers prompt templates. The evaluation prompt template is a straightforward, user-friendly prompt template detailing the instructions for evaluation. It includes brief examples, metrics, and the format for responses. The production prompt template offers the same, but for production use. This template gets hydrated during production runtime and is the one for performance evaluation. There we go. Everything looks good. When evaluating prompt templates, input dataset options include a golden dataset with labeled data specifically for evaluation and a dataset derived from production traffic, also used for evaluation purposes. Each template gets evaluated considering its specific instructions, context-involved models, and model parameters. To provide a high-level comparison of different prompt templates' effectiveness, aggregated metrics get generated by applying the prompt templates across a large dataset. So this is prompt evaluation flow. So we've got authoring the flow, and we've got testing the setup. So we've got a loop here for authoring the flow. And notice that this line is only one way. So we start here and then we move down. So authoring the flow is a continuous loop of authoring the prompt, creating and testing the response until you get. So then that moves down to your testing framework, which has your test cases, sample conversations, evaluation framework, and reporting metrics. And then it goes into your confidence score. So and then it gets onboarded as your prompt. And this is it as well. And there's no option for yes, so I guess that's a bit confusing. But anyway, moving on to hopefully the final section. Nope, not the final section at all. Not even close. So the next section is use cases at Uber. Let's see how the prompt toolkit works for some production use cases. Uber. And so we can see we've got a mistake here. It should say, let's see how the prompt tool case uses for some production use cases, and it's missing the word at Uber. So offline LLM service, the LLM batch offline generation pipeline facilitates batch inference for large-scale LLM response generation. For example, this pipeline can be integral to the rider name validation use case, which verifies the legitimacy of consumer usernames. It assesses all existing usernames in Uber's consumer database, as well as those of newly registered users, employing an asynchronous method to process and generate responses for usernames in batches. In MA Studio, setting up this offline generation pipeline is straightforward. Users select the relevant dataset and input it as data. The prompt template is dynamically hydrated with this dataset. For example, if the user's prompt template includes the sentence, is this username a valid human username, the pipeline extracts the username column from each data row, using it to generate a custom prompt for each entry. So that could be useful. You can verify all of everything in a spreadsheet by feeding it in. So prompt offline generation. I'm not sure what they mean by that. Probably I'm not sure what they mean by that. Well, here we go. Live in the modern world, so let's live in the modern world. In one sentence or so, explain to me what they mean by offline generation in this context. So it refers to a process where prompts are prepared and processed in bulk using a predefined pipeline without requiring real-time interaction to generate responses and store the results for later use. So would this be kind of like some sort of like internal dialogue that humans have? Is that kind of like what this is meant to do, or is that just completely Not the same. It's not. No, it's not the same. There is a loose analogy to be made, but offline generation is more about preemptively running through a structured process. Okay, well, is there an analogy to be made that is a lot tighter? Could you tell me what that would be in like a sentence or so? Oh, okay. So like using a teleprompter. Would that be a better analogy? Yes. Okay. It's like, okay, or like actors reading from a script or like memorizing Shakespeare and yeah. Okay, I get it now. Yeah. Okay. Cool. Cool. I like that. We live in the modern world, so if you're confused by anything, you can get even more confused by learning an LLM hallucination. But I think they're pretty good by now, especially if you're using the latest models. If you're using the older models or the mini versions, that could be more prone to hallucinations. But I think the 4.0 is pretty good. Like, you know. All right. So, online LLM service. The prompt template contains dynamic placeholders that need to get replaced with specific runtime values provided by the caller. The caller is responsible for hydrating, whatever that means, and passing the values that must get substituted on the placeholders. The model's hyperscale service currently supports substitution using Jinja-based template syntax. At the moment, we only handle the substitution of string types. This service also supports fan-out capabilities across prompts, templates, and models. The fan-out capabilities can be divided into templates. The API templates include formatting the payload into a vendor-specific API structure from the generic data model we expose from the service. Multiple templates, such as chat completion and text completion templates, are supported. The other fan-out capability is prompts and models. The prompts are pinned to a specific model and template. The service fetches the prompt and now there's another typo there, it should say calls with an S, the GenAI APIs with the required model and template parameters for execution. Let's explore the above functionalities through a summarization use case. A contact is a support ticket used to contact a customer support agent. There are scenarios where multiple agents can handle a contact. In this case, the new agent receiving the handoff must either go through the ticket to understand the context or ask the customer to reiterate the problem. Usually it's the former. To solve this, we would provide a summary to the agents when there's a handoff from one agent to another. So this is prompt execution and summarization flow. So we've got, so it transfers to an agent. So when you call in for customer service, it'll transfer you to an agent. Then you get your channel manager, which you're dead in the water. There's no arrow going the other way. I feel like this here is meant to be an arrow, but it's too close together to have rendered properly. In Mermaid is probably what they're using. So yeah. Then it goes to your orchestrator. Oh, but that's interesting. These are one way. Huh. Alright, so this is a bit beyond me. That's fine. Let's just try to get... so we're very nearly done with this article. So next section is monitoring. Monitoring measures the performance of the production prompt template used in production. The purpose is to track the regression and performance of the currently prompt template. Oh, and there's another error here. currently is meant to say current, of the current prompt template in production. A daily performance monitoring pipeline runs towards production traffic to evaluate the performance. Metrics include latency, accuracy, correctness, and more to monitor each prompt template production iteration. An MES dashboard gets refreshed daily with performance monitoring metrics. Refer to the MES blog post for more information about the MES dashboard. That's too much detail. So the conclusion: the prompt engineering toolkit outlined in this blog represents a comprehensive framework designed to enhance the interaction with and utilization of LLMs across various stages of development and production at Uber. Deployment is something else. From the initial exploration of LLM capabilities in the Gen AI playground to the detailed iteration and creation of prompt templates, the toolkit facilitates a dynamic environment for both novice and expert users to harness the power of LLMs effectively. The architecture of the toolkit allows for a systematic approach to prompt design, incorporating advanced guidance techniques and robust evaluation methods to ensure the production of high-quality, effective prompts. The structured lifecycle of prompt templates, from development through to production usage and monitoring, ensures that each template is rigorously tested and optimized for performance. As a next step, we hope to evolve the prompt toolkit to integrate with online evaluation and with RAG for evaluation and offline generation. And we can see here about LangChain. LangChain is a trademark of LangChain Inc. Registered with patent and trademark object. Oh man, that's too bad. Oh, it's under the MIT license though. Permiso open source. Okay. All right. Well, so that's the first article he sent me. I'm not sure if he wants me to go and make a hour-long video for each article he sends me. I think that's probably the opposite of what he wants. He wants me to work on my assignment, which is some which is automated prompt engineering. He wants me to do prompt engineering. So that's definitely. But I think these are. He does want me to look over these, maybe not in as much detail as I am, but and it'll help. It'll help for sure, I think. But I'm usually only good for an hour before it's very difficult for me to continue any further. But I have found that using the Pomodoro technique and just taking like a 15-minute break allows me to do another hour pretty easily. So I'm going to pause it. I'm going to take that 15-minute break, do something else, and then come back and see if I can do more time. So I'm going to pause it, and I'll be right back. All right, welcome back. So it's been about 15 minutes, more or less, more like 20. But hopefully this will allow me to go on longer. So the next article, so I could do that. I could read another article that was kind of a natural stopping point after reading that other one. But really what I want to get down to is the actual stuff. So we got a README here that specifies the assignment more clearly. We've got so I want to get into VS Code and out of the browser, but let's finish this up. It might take a while, but hopefully this way of going about it, this more Pomodoro method style will work. So this next article is Query GPT, Natural Language to SQL. Using generative AI. So this is an important part of our project. We wanna target all of the languages out there, including domain-specific languages like SQL. Introduction. SQL is a vital tool used daily by engineers, operations managers, and data scientists at Uber to access and manipulate terabytes of data. Crafting these queries not only allows a solid understanding of, and SQL is sometimes pronounced SQL as well, so I'll also saying SQL syntax, but also deep knowledge of how our internal data models represent business concepts. Query GPT aims to bridge this gap, enabling users to generate SQL queries through natural language prompts, thereby significantly enhancing productivity. Query GPT uses large language models, LLMs, vector databases. So vector databases are an alternative. So there's a lot of different kinds of vector data of databases. SQL is a vital tool for sure, but it's not the only domain-specific language or the only way to interact with databases. And similarity search to generate complex queries from English questions that are provided by the user as input. This article chronicles our development journey over the past year and where we are today with this vision. So motivation. This is the author querying process. So we start here, get the data book, found relevant data sets. If not, then we search sample queries, ask data owners, and then we do that until we get the author query. Hopefully we get it right away. Then we get the data. If it's the correct data, then we're done. Or we can be directly done if we don't care if it's correct or not. And if it's not correct, we go back to the data book. At Uber, that's an interesting. That would be a good company name, Uber, rather than Uber. I mean, it's pronounced that way already by a lot of people, I bet. At Uber, our data platform handles approximately 1.2 million interactive queries each month. The operations organization, one of the largest user cohorts, contributes to about 36% of these queries. Authoring these queries generally requires a fair amount of time between searching for relevant data sets in our data dictionary and then authoring the query inside our editor. Given that each query can take around 10 minutes to author, the introduction of Query GPT, which can automate this process and generate reliable queries in just about 3 minutes, represents a major productivity gain. If we make a conservative estimate that each query takes about 10 minutes to author, Query GPT can automate the process and provide sufficiently reliable queries in about 3 minutes. This would result in a major productivity gain for Uber. So here's the Query Builder usage, figure 2. So we've got Query Builder, Uber Ops. So there we go. This is an example of usage. Then we've got the Query GPT impact. There are fewer iterations and errors. There's some big errors you can get with SQL if you query the entire database that can overwhelm the CPU and memory, from what I understand, and you can sync your system. It's like a self-destruct button. You can reduce the cognitive load. So SQL is a domain-specific language that comes with a lot of pitfalls. The fewer iterations and errors, the better. We can see they reduced their queries down to 3 from 10, and for each of them from about 10 rounded up to 10, and then for each of them they reduced each query from taking 10 minutes long to only taking 3 minutes long. So they now have 9 minutes of queries in their database, where before they had 100 minutes. So they took it from over an hour, about an hour and a half, down to 3 minutes. Like, how about that? I'll take that. And that resulted in 18% ops productivity gain per day, which is surprising. It's so low. Well, I guess you just need to get it out of the way, and then once it's done, it's done. So, but hey, you know what? We live in the modern world, so let's have a conversation about that. All right, in one or two sentences, tell me what you think about this graphic. Okay. Are you surprised that their productivity gain is only 18% when they were able to take their query time down from about an hour and a half to only 3 minutes? Their total query time, according to my math. Feel free to double check my math and see if it's correct. Yeah, I'm about correct. Yeah. Yeah. Okay. Yeah, that makes sense. Even though they got a 90% reduction in query time, reducing that query time by 90% only led to an 18% gain in the overall productivity in the department. Yeah. Okay, we'll just list out like 3 to 5. Sorry, there are some typos, but it should be clear given the context what I'm asking you to do. Right now I'm asking you to do something, and I'm asking you to make a list of 3 to 5 other things you think they could optimize by like 90% or more, like they did with their query time, where they would gain another improvement on their total productivity, even if it's only like, 10% or less of a improvement. But give me something that wouldn't be that hard to optimize. Okay, so error resolution time, whatever that means. Knowledge search. Port generation, task. Yeah. Alright, anyways. Next section is architecture. Query GPT originated as a proposal during Uber's generative AI hack days in May 2023. Since then, we have iteratively defined the core algorithm beyond Query GPT, transitioning it from concept to production-ready service. Below, we detail the evolution of Query GPT and its current architecture, highlighting key enhancements. We've described below our current vision of Query GPT. Please bear in mind that there were about 20 plus iterations of the algorithm between the two detailed below, and if we were to list and describe each, the length of this blog article would be put in Ayn Rand's Atlas, would put Ayn Rand's Atlas Shrugged to shame, and it's kind of telling that they picked this as their example of a book that is long. Because there are, I think, a lot of how long is the book Atlas Shrugged by Ayn Rand? Is it a good book to use like in a joke about like books being written long, or does it kind of like not make sense? Like wouldn't like Infinite Jest or War and Peace make more sense? Yeah, that's not that many pages. Oh. Actually, never mind. It is a lot. Okay. No, that makes sense. 1,200 pages is comparable to some of the longest books ever written. But not I've ever written. Sorry, there are some typos here, but I think that makes sense. Yeah, it works well. Yeah, okay, that's fine. I think most people would say War and Peace there, but War and Peace is shorter than that book, so. Alright, so next one is Hack Days version 1. Query GPT Hack Days version, Figure 4, natural language prompt, SQL query and explanation. The user does that, and it goes through this whole system. Okay, so the first version of Query GPT relied on a fairly simple reg to fetch the relevant examples we needed to include in our query generation call to the LLM, few-shot prompting. we would take the user's natural language prompt, vectorize it, and do a similarity search using k-nearest neighbor search on the SQL samples and schemas to fetch 3 relevant tables and 7 relevant SQL samples. The first version used 7 tier 1 tables and 20 SQL queries as our sample dataset. The SQL queries were supposed to provide the LLM guidance on how to use the table schemas provided, and the table schemas provided the LLM information about the columns that existed on those tables. For example, for a tier 1 table, uber.trips_data, not a real table, this is what the schema would look like. Alright. To help the LLM understand internal Uber lingo and work with Uber datasets, we also included some custom instructions in the LLM call. Shown below is a snippet of how we wanted the LLM to work with dates. So, data type functions and comparisons. It's important to consider the data type of columns in a given dataset because certain functions can only be applied to some column types. For example, date functions like those can only be used with timestamps, and these can only be used on strings. Yeah. So you have to know the data type so that you can know what functions are valid and which are not. We would wrap all the relevant schema samples, SQL samples, user's natural language prompt, and Uber business instructions around a system prompt and send the request to the LLM. The response would include a SQL query and an explanation of how the LLM generated the query. So here's the explanation, here's the SQL query. This is the first generated SQL. Oh, so this is a generated SQL with explanation. So, okay. And this is the response to the prompt. The prompt is not shown here. So, the LLM gave back it looks like JSON with an explanation key and a SQL query key. The explanation key just gives you a plain text explanation, and then from that it gives you the actual SQL, which is cool, which is good stuff. That's cool, and you could see that you could do that with things like because I'm a networking guy, you could do that with like Splunk. Like you could build in network security things where it's like it'll give you a more clear explanation about what exploit it's actually looking for and like what filtering you actually have to do to detect whether or not those have been successful on your network or on your systems. So yeah, lots of potential here. While this version of the algorithm worked well for a small set of schemas and SQL examples, as we started to onboard more tables and their associated SQL samples into the service, we started seeing declining accuracy in the generated queries. Better reg. Doing a simple similarity search for a user's natural language prompt, find the number of trips completed yesterday in Seattle. On schema samples, create table and SQL queries, select ABC from uber.foo, doesn't return relevant results. Understanding user's intent. Another issue we found was that it's incredibly challenging to go from a user's natural language prompting to finding the relevant schemas. What we needed was an intermediate step which classifies the user's prompt into an intent that maps to relevant schemas and SQL samples. Handling large schemas. We have some really large schemas on some tier 1 tables at Uber, as you can imagine, with some spanning over 200 columns. These large tables could use up as much as 40 to 60,000 tokens in the request object. Having 3 or more of these tables would break the LLM, since the largest available model at the time only supports 32,000 tokens. Current design. The diagram below shows the current design of Query GPT that we're running in production. The current design includes many iterative changes from the first version. So this is Query GPT current design, and we can see we got a lot here. All right, so the next section is workspaces. In our current design, we introduced workspaces, which are curated collections of SQL samples and tables tailored to specific business domains such as ads, mobility, and core services. These workspaces help narrow the focus for the LLM, improving the relevance and accuracy of generated queries. We've identified some of the more common business domains inside Uber and created those in the backend as system workspaces. Mobility is one of these system workspaces that we identified as foundational domains that could be used for query generation. Mobility, queries that include trips, driver, document details, etc. Write a query to find the number of trips that were completed by Teslas in Seattle yesterday. Along with these, we shipped 11 other system workspaces, including core services, platform engineering, IT ads, etc. We also included a feature that allows users to create custom workspaces if none of the existing system workspaces fit their requirement, and use those for query generation. All right, next section is intent agent. Every incoming prompt from the user now first runs through an intent agent. The purpose of this intent agent is to map the user's question to one or more business domains / workspaces, and by extension, a set of SQL samples and tables mapped to the domain. We use an LLM call to infer the intent from the user question and map these to system workspaces or custom workspaces. Picking a business domain allowed us to drastically narrow the search radius for reg. Next, we've got a table agent. Allowing users to select the tables used in the query generation came up as feedback from some users who saw that the tables were eventually picked by Query GPT were not correct. To address this feedback, we added another LLM agent, table agent, that would pick the right tables and send those out to the user to either hack or edit the given list and set the right tables. A screenshot of what the user would see is shown below. So we've got Query GPU. Okay. Asking me a question. Okay. Find the numbers. Planning to use the tables. All right. Table agent. The user would either select the looks good button or edit the existing list and modify the list of tables to be used by the LLM for query generation. Next section is column prune agent. Another interesting issue we ran into after rolling Query GPT out to a larger set of users was the intermittent token size issue during query generation for some requests. We were using the OpenAI GPT-4 Turbo model with 128,000 token limits, 1106. But we were still seeing token limit issues because some requests included one or more tables that each consumed a large amount of tokens. To address this issue, we implemented a column prune agent wherein we use an LLM call to prune the irrelevant columns from the schemas we provided to the LLM. Here's what the output from the agent looks like. All right, so same thing. We've got a column prune agent. Okay. The output would include a skinnier version of each schema that we needed for query generation. This change massively improved not just the token size and by extension the cost of each LLM call, but also reduced the latency since the input size was much smaller. Output. No changes were made to the output structure with the current design. The response would include a SQL query and an explanation from the LLM about how the query was generated, similar to what's shown in Figure 7. Evaluation. To track incremental improvements in Query GPT's performance, we needed a standardized evaluation procedure. This enabled us to differentiate between repeated versus anomalous shortcomings of the service and ensure algorithm changes were incrementally improving performance in aggregate. Next section is evaluation set. Curating a set of golden question to SQL answer mappings for evaluation required manual upfront investment. We identified a set of real questions from the Query GPT logs and manually verified the correct intent. Schemas required to answer the question and the golden SQL. The question set covers a variety of data sets and business domains. Next is evaluation procedure. We developed a flexible procedure that can capture signals throughout the query generation process in production and staging environments using different product flows. All right, and there's a lot more to this article, probably about halfway through. But here is the evaluation procedure. So we've got the product flow, the purpose, and the procedure. So the first product flow is vanilla. The purpose is measures Query GPT's baseline performance. The procedure is input a question. Query GPT infers the intent and datasets needed to answer the question. Generate the SQL using infer datasets and intent. Evaluate intent, datasets, and SQL. The next product flow is decoupled, measures Query GPT performance with the human-in-the-loop experience, enables component-level evaluation by removing dependencies on performance on earlier outcomes. And then the procedure is input a question, intent, and datasets needed to answer the question. Query GPT infers the intent and datasets. Generate the SQL using the actual not inferred intent and datasets. Evaluate intent, datasets, and SQL. For each question in the evaluation, we capture the following signals. Intent. Is the intent assigned to the question as accurate? Table overlap. Are the tables identified via search plus table agent correct? This is represented as a score between 0 and 1, which should be pretty familiar numbers for those who have learned about neural networks. Those can be used as weights. For example, if the query needed to answer the question, how many trips were canceled by drivers last week in Los Angeles, required the use of fact trip state dim city and Query GPT identified dim city fact each trip. The search overlap score for this output would be 0.5 because one of the two tables required to answer this question was selected. Successful run. Does the generated query run successfully? Run has output. Does the query execution return greater than 0 records? Sometimes Query GPT hallucinates filters like where status equals finished when the filter should have been where status equals completed. Yep. Resulting in a successful run with no output. Yeah, so sometimes, yeah, exactly. Qualitative query similarity. How similar is the generated query relative to the golden SQL? We use an LLM to assign a similarity score between 0 and 1. This allows us to quickly see if a generated query that is failing for a syntactic reason is on the right track in terms of columns used, joins, functions applied, etc. We visualize progress over time to identify regressions and patterns, revealing areas for improvement. The figure below is an example of question-level run results, enabling us to see repeated shortcomings at an individual level. Is query errored, false or true? SQL query evaluation. There we go. SQL query evaluation across environments. For each question, we can view the generated SQL, reason for the error, and related performance metrics. Below is a question whose generated query is regularly failing because it is not applying a partition filter in the where clause. However, according to the qualitative LLM-based evaluation, the generated SQL is otherwise similar to the golden SQL. So this one failed. We can see true, query has failed. The product flow was vanilla, and there's a missing partition filter. There's no output associated with it because there's a missing partition filter. So there we go. We also aggregate accuracy and latency metrics for each evaluation run to track performance over time. All right, limitations. Due to the non-deterministic nature of LLMs, yeah. Right. Exactly. And I'm going to send this to, I feel like I'm going to pause it quick and then send this to, all right, so I'm back. Yeah, I just wanted to, I'm not making a point or anything. I'm sure he already knows. I just wanted to send that. So due to the non-deterministic nature of LLMs, running the same evaluation with no changes to the underlying query GPT service can result in different outcomes. In general, we do not over-index decisions based on the around 5% run-to-run changes in most metrics. Instead, we identify error patterns over longer time periods that can be addressed by specific feature improvements. Uber has hundreds of thousands of data sets with varying levels of documentation. Thus, it is impossible for the set of evaluation questions to fully cover the universe of business questions that a user may ask. Instead, we curated a set of questions that represent the current usage of the product. As we improve accuracy and new bugs arise, the evaluation set will evolve to capture the direction of the product. There is not always one correct answer. Often the same question could be answered by querying different tables or writing queries in different styles. By visualizing the golden versus returned SQL and using the LLM-based evaluation score, we can understand if the generated query is written in a different style, but has a similar intent related to the golden SQL. All right, and this is what they learned, so that's good, and the article's almost done, which is even better. Working with nascent technologies like GPTs and LLMs over the past year allowed us to experiment and learn a lot of different nuances of how agents and LLMs use data to generate responses to user questions. We've briefly described below some of the learnings from our journey. LLMs are excellent classifiers. Our immediate agents that we used in Query GPT to decompress the user's natural language prompt into better signals for our RAG improved our accuracy a lot from the first version, and a lot of it was due to the fact that the LLMs worked really well when given a small unit of specialized work to do. The intent agent, table agent, and column prune agent did an excellent job because they were asked to work on a single unit of work rather than a broad generalized task. Hallucinations. This remains an area where we are constantly working on. But in a nutshell, we do see instances where the LLM would generate a query with tables that don't exist or with columns that don't exist on those tables. We've been experimenting with prompts to reduce hallucinations, introduced a chat style mode where users can iterate on the generated query, and are also looking to include a validation agent that recursively tries to fix hallucinations, but this remains an area that we haven't completely solved yet. All right, and then user prompts are not always context rich. Questions entered by the users in Query GPT ranged from very detailed with the right keywords to narrow the search radius to a 5-word question with typos. To answer a broad question that would require joins across multiple tables. So they ranged from very detailed with the right keywords to narrow the... Oh, there should be the word from in here because it says questions entered by users in Query GPT ranged from very detailed with the right keywords to... Yeah. Well, no, so there is the word from in here. It's here. So they ranged from... Okay, and then the word to here kind of throws things off. So very detailed with the right keywords. I think this should say that. That narrowed the search radius to a 5-word question to answer a broad question that would require joins across multiple domains. So that's a problem. This is not written very well because it ranges from one end of the range to the other, and it seems to only specify one end of the range and not the other. Anyway, the next one is solely relying on user questions as good input to the LLM caused issues with accuracy and reliability. A prompt enhancer or prompt expander was needed to massage the user question into a more context-rich question before we sent those to the LLM. High bar for SQL output generated by the LLM. While this version of Query GPT is helpful for a broad set of personas, there is definitely an expectation from many that the queries produced will be highly accurate and just work. The bar is high. In our experience, we found that it was best to target and test with the right personas as your initial user base when building a product like this. Alright, so here's the conclusion. The development of Query GPT at Uber has been a transformative journey, significantly enhancing productivity and efficiency in generating SQL queries from natural language prompts. Leveraging advanced generative AI models, Query GPT seamlessly integrates with Uber's extensive data ecosystem, reducing query authoring time and improving accuracy, addressing both the scale and complexity of our data needs. While challenges such as handling large schemas and reducing hallucinations exist, our iterative approach and constant learning have enabled continuous improvements. Query GPT not only simplifies data access, but also democratizes it, making powerful data insights more accessible across various teams within Uber. With our limited release to some teams in operations and support, we are averaging about 300 daily active users, with about 78% saying that the generated queries have reduced the amount of time they would have spent writing it from scratch. As we look forward, the integration of more sophisticated AI techniques and user feedback will drive further enhancements, ensuring that Query GPT remains a vital tool in our data platform. Perfect. Alright, so that's it for reading the articles. So next I want to get into VS Code and actually work on this assignment, which we're calling Apeman. So I'll briefly read the synopsis of what the assignment is. So I'm going to start with QA tools. I'm going to start with ESLint first, but then I'll move on to Python Black and HTML Beautifier. And for each of their dependencies and plugins, I want to okay, so I actually want to and so okay, and all this so let me type this out, and this keyboard, my this is gonna say for each, and then what we're gonna do is we're going to install, configure, execute, consume. Okay. And then so let's put this in there. Oh. Let's see here. All right, and I'll just put these words in here because those words might matter. I'll put that in there as well. Just trying to build out these notes here because I do want to create a good README for this. That makes sense. So I'll put all of this in here. Okay, this is about Mentor Hub. I can get rid of a lot of this. Oh, let me move this one to the end because I want to work on that at some point. I've got way too many open. Let me get this on there. Alright, let's get that on there. I just want to start by making a clearer README that really like spells out what I'm actually doing. Yeah, that belongs in there for sure. Okay. Oh, right. Okay, so this is for something else. Oh, SWOT analysis. Yeah, yeah,
Okay. Oh, that was probably not good to show. Oh, and this is something actionable that I probably fell through on. Probably not good to show either. 7 business days. I should have called back on that. Man, I have a lot of, oh. Okay, I have a lot. This stuff is before micromanagers, so that's okay. A lot of it can be closed. All right. Okay, so yeah, that's all I need for here. So let me start by getting this README better. So, Apeman, is a manual. We'll do it in Markdown. Oh, it is in Markdown. So we'll do Apeman manual precursor to Ape. We'll say Apeman is a manual prompt engineering project that kicks off a larger effort we'll say what is, yeah. Okay, so here we'll say what is Apeman. We'll say Apeman is now meant to kick off a larger ape feature of micromanager. We'll say visit code cartel codes to learn about this project. Okay, we'll say let's get a preview of what it looks like. There we go. What is Apeman? Okay. We say goals of Apeman. Okay, so we're gonna say starting with ESLint Python plug. All it depends on plugins. Plugins. Manually experiment with writing a prompt that produces an output from any LLM that successfully installs, configures, executes, for is consumes. Each of the QA tools, and that can a QA tool, and that can serve as a template with variables that can be filled in automatically to do the same for other QA tools. There we go. So starting with ESLint, Python Black, and all of their dependencies and plugins, manually experiment with writing a prompt that produces an output from any LLM that successfully installs, configures, executes, and consumes a QA tool set to its highest code quality standards. Configured to its highest code quality standards. That can and say the prompt must serve as a template with variables that can be filled in automatically to produce the same result for other QA tools. I'm going to say the result is a bash script, is a functional bash script. Yeah, so the result is a functional bash script. There we go. So next section will be something else. And then, so there we go, goals of 8. Yeah, so Apeman, manual precursor to 8. Yep. There's Apeman. Okay, that's what it is. Goals of Apeman. Okay, and put this on another line, just because I think that looks better. Oh, even though I'm not able to do that for some reason. Oh, it was just delayed. There we go. Okay. Oh, and now we've got oh, okay. It's just because it's selected. Oh, it's just showing where my. Okay. Produced from, we'll say, produced from a generic template that had ran through. The result is a functional bash script produced from a generic template with data filled in to it from a spreadsheet of QA tools. Perfect. With variables filled in from a spreadsheet of QA tools. All right, so now we've got okay. So say relevant concepts. Say prompt engineering. Okay. Okay, and then we'll say notes for the rest of this. Okay. Okay, I'll start there. So do git status. Now we've got this files to process. I'll get rid of that. I don't need that. Okay. Oops, and it looks like that had really unpredictable effects. It opened my browser and then it opened a new tab on my browser relating to the camera. So hopefully, I'm not sure what happened there, but hopefully it won't be an issue. I probably accidentally hit a hotkey on my keyboard. So let's do a git status. Oh, these are untracked files, so I probably got some tracked ones. Yeah, I've got. So let's just look at the changes. So I've got 2 workspaces open here. I've actually got a number of workspaces open here, but we're doing Apeman. So Apeman, yeah, I added all that to the README. I want that. Then I did that. I got rid of that file. Let me just do everything. So, you know what I can do? I can just do it for the one. So let me stage the one. I'm gonna say filled out README more completely. Want to create a clear and comprehensive README first. Okay, commit that. And then I should be able to push it. And yeah, I would like it to run git fetch periodically. Okay, so there we go. And for anyone who doesn't know, git fetch pulls down changes but doesn't merge the changes in. Git pull is a macro that runs 2 commands. It runs git fetch and then it runs git merge. So there really is no such thing as doing a git pull. Pull is an alias. It's a macro for fetching and merging. So it's nice to have git fetch because it'll just fetch down the changes, and then it won't interfere with what you're doing because it won't apply the changes until you say so. So you can see if someone else you're working with did something, and then you can continue your work. It won't try to merge it and then conflict with what you're working on. So git fetch is a good. You can pretty much hit yes whenever that shows up. If you're really new to this, it might be confusing, but it shouldn't be all that disruptive. It would be disruptive if it automatically tried to merge it in. Did it get pull? But I mean, this is going to be confusing any way you cut it. Like it's just confusing to work with Git. I'm surprised there's not a better way so far, but. Let's look at the clock. So I'm well past 2 hours here. So what I could do, let me do that. So I spent an hour on each of those articles. So let me take another Pomodoro style 15-minute break, and then let me spend an hour on VS Studio Code and trying to do everything here for Apeman. And we can remove some of these other ones. So we'll move that from the workspace. And close it. Oops. There we go. Now we've only got the one open. That should be easier. If we need it back, we can just do File and add folder to workspace very easily. So oops, and I added one by accident. So let's remove that one. There we go. So yeah, that makes it clearer. So now that I've got an hour knocked off, let's do 15-minute Pomodoro style break again. Do another hour and then call it for this video. I mean, if I'm posting 12-hour videos, that's a bit much. So just a 3-hour video, I think would be about the perfect time. So. With that, I'll be back in about 15 minutes, and then I'll put in another hour, and we'll have about a 3-hour video here. All right, I'm back. So I'm going to make this about a 3-hour video. So I'm going to put another 45 minutes or so in for that. Hopefully I'll go over, and I'll have 3 hours on the clock here. So 3 hours on the board. So we've got some changes here pending. Yeah, so we've got my station template, and then we've got yeah. So let's continue filling out this README. So yeah. So let's take a look at the preview. So what is Apeman? Goals of Apeman, relevant concepts, and the relevant concepts. Don't have a for some reason there's no new line. So oh yeah, there we go. That's better. Okay, there's relevant concepts. There we go. Now let's do components. Okay, and then we're gonna have the station template. And what this does is it used to so it contains train track pseudocode. Controlled contains variables filled in by QA tool data. Contains say configures, installs, configures, executes, consumes. Okay. Fed to LLM. Converts to bash. Okay. So that's one major component is the station template. Another component of ape. Okay. So another component is mocker. Fills, and this fills in the station template variables in a loop using the QA tools spreadsheet. So then, of course, there's another component that is the QA tools spreadsheet. And I'll make a link for that. So that would be right here. Alright, so there we go. There's more components than that, but that's where I'm going to start. Okay, so this is good. So yeah, we start with the. I'm gonna move this up. Okay, I'm gonna move this up. to the top of the notes. And then add a differentiator there. Okay, and I'll put this into sections. And I'll put these in the bullet notes. Okay. Let's see what that looks like. Pretty sure in Markdown I can do like that. Yeah, I can do that. Oh, it has to be indented at the same level though. All right. This is more bash, so let's do that. Oh, okay, let's put this up to be a part of this. Make this bash. Okay, so that looks better. Yeah, so that's the notes. Apeman. Okay, and then there's more notes as well, but okay, so I'll commit this. And I'll say organizing section, commit and push. Okay, looks good to me. All right, so the other thing, yeah, so yeah, so we should have the station template. Yeah, here's the station template. All of that is in the README, so that can be taken out of the station template. There we go. Station use, and then this will fill in that. So we should also have the spreadsheet. So let's download the spreadsheet. as a CSV. Okay, and then we'll put it in the downloads folder, and then move that over to here. Okay, I forget what I named it. Micromanager to do. There it is. Don't want a CD, we want to move that. Oops. No such file or directory. Did I spell it right? Nope, I didn't spell it right. I need a C. There we go. Okay, so now it's showing up there. Tools.csv, let's open that. Okay. And let's rename that. All right. Okay. All right. See what I got for time. Queue it. Okay. Station template. All right, I can commit this. Okay, push that. All right, and then I can commit the station template. Let's move to README. Okay, push that. And then this is the this is for running Mocker. Yeah, this is just junk code, so let me get rid of that. So here's the original file on the left. Okay, the original file doesn't have anything in it. And this is all wrong. It should say use the station template to automate installation, configuration and testing of tools, and then you use Mocker to generate a station file out of the station template to do that for another tool. So I'm just going to get rid of this here because it's just not descriptive. Okay, and I'll let me commit that change and say the description's wrong. Correct. Mocker is to fill out the station template in a loop for each QA tool. The station template is to generate a train track script. All right. So what's next? Yeah. So here's a prompt. That's the preamble. Yeah, it's the only. Okay, so this file is important. This was written out by Drew, so that's going to be a key. This is another one that he wrote out, which will be important. I can get rid of this folder. It's not necessary. This isn't necessary either. Oh, well, this used to, yeah, that's not necessary to have in a folder either, so I'll take it out, move it to a folder when it needs to be in one. Okay, and then commit those changes. We'll move. We'll put files in folders once the need to do so is more apparent. Okay, so there we go. Now we've got the files. So I should fill out I should make sure that the components part of the README is up to date. So we've got the station template is here. I hate how it. Let me ask ChatGPT about something. Or actually, I can just figure it out. So we'll do Control P. We'll do editor replace. We'll just do editor. Oh. Our Explorer. Or just replace maybe? Ah. Alright, let me go to settings, or preferences, settings, text editor, should be. All right, well, let's go to ChatGPT for this. Okay, so when I'm using VS Studio Code, one of the most annoying things that happens is I try to open a file and it closes another file that I had open. So, like, how can I make sure that the other file doesn't close? I mean, I guess it doesn't matter because I can just click on it in the Explorer window. But I just want the file to remain open. Like, it disappears from my consciousness when it closes. So, like, even though it's more efficient probably to, like, do it in a way that it closes, I just want to not have it be that way because it doesn't work as well with my thought flow. Preview mode. Yeah. Get rid of that. Oh, yeah, that did it. Okay. Yeah, so you have to disable preview mode, and then they open and stay open. And yeah, it is more optimal to do this, because otherwise you have to go all the way over, mouse over much further. So this is the way to do it. Alright, perfect. Okay, so this is the, so let's go back to the README. Okay, and look at the components. So we got the station template here. We've got mocker. So let's create an empty file for mocker. And we can get let's get mocker. Let's just generate mocker from the LLM. I can write it in Python, but we'll write it in Bash, and we'll just try to get this going here. So we'll do this. Open up this. Okay. Alright, and then we'll look at Mopper. So, okay, produce for me. So write the Mocker. Oh, I probably have to give it the. I have to give it this, the QA tool spreadsheet as well. Okay, now I'm gonna say, write the complete Mocker bash script for me. Include only the code and nothing else. Make sure that the code is complete. All right. So start with that. Okay, so now we've got the station template, we've got Mocker, and we've got the QA tool spreadsheet. So Mocker will take the QA tool spreadsheet. It will give an error if it can't find it. It will create an output directory for generated scripts. Then it will process each line. Okay. Define the then we'll name a file. So it'll be install.sh for the name of the tool. I'd like to do that in a lowercase if I can. Can this convert it to lowercase? Okay, so yeah, we can use to ensure that the generated script files in lowercase. You can use the to-r command. Okay, yeah, let's do that. All right. Then generate the script using a template. Okay. And now, what is with the? Oh, so here's the template. Okay, and it's gonna fill in these blanks. Make the generated script. All right, so let's test that out, and that'll be a good place to start. Oh, and sometimes my keyboard doesn't behave. So we're gonna do bash mocker.sh. There we go, and we've generated all of the scripts with all of their names in lowercase. So let's do one more thing with this line here. Oh, sorry, that's the wrong one. We need to go to Mocker. Can just work on Mocker. Yep, we'll deal with this. Oh, not this. We'll deal with yep, this right here. Can you make the names more uniform by correcting dog, cat to instead be, and dog space cat to instead be dog cat. Yeah. All right, let's do that. Okay, and then it's all in its own folder, so we can get rid of that folder. Delete permanently. Yes. Okay, so now it should work better. Okay, I like that. I like that a lot. Okay, so let's feed another thing to the LLM. We're gonna do a clear, then we're gonna do ls generated scripts. Okay, we're gonna perfect. Here are the results now. So we're gonna feed it this. We're gonna say perfect. Above are the results. Are there any other optimizations in the naming you think might be necessary? Yep, no, it looks good. So, oh, there's some double underscores. Okay. Grouped under PHP tools. I mean, it could do that. It could put each tool in its own folder. Oh, really? Okay, so okay, implement, we'll say implement 1 and 4, please. And let's see what the other ones. Yep, implement 1 and 4, please. Oh, see, this removes a prefix. Normalize the tool name. Yeah, this looks good. Oh, it does it in 2 steps. Yeah. Okay. There, I like that better. Perfect. Okay, so now I can delete this whole thing. Then run mocker again. Okay. Oh, you know what? It looks like it didn't do it as well this time. No, I liked what it had better last time, so let's go back to that. Yeah, this is better. Okay, now some do have double underscores, but it doesn't really matter. I'm not seeing any that have double underscores. It doesn't matter. It's not meant to be read by humans. It's meant to be read by the machine. So it really doesn't matter. There could be emojis in the title. It doesn't matter. All right. Yeah, I'm really happy with that. So that's it. So we'll delete that permanently, and then we'll go to the version control. Look at the difference. So we've got mocker. So generated a mocker file that creates a station script from the station template for each QA tool. Oh, All right, that looks good. It is now 4:41 p.m. This is a decent time. So let's see what the video has got. Okay, so I can do more time on this. That's okay. So we'll go back to the README, go back to the components. So we've got the station template. We'll open that. That's in TrainTrack, which is a pseudocode standard invented by Drew. It's really important to our project going forward. It's one of the things that'll set us apart. Then we've got Mocker. And then this is where it gets interesting because then we have the station template. So the station template is here. So I'm gonna overwrite this station template. Okay, so what we're gonna do is we're gonna go back to the LLM and we're gonna say perfect. Now let's move on to another task. Next, we will create a station template in the Mocker script in the section that says generate the script using a template. Instead of having that cat syntax, what we're going to do is we're going to have that template be a station template, and we're going to have that written in a special pseudocode standard known as TrainTrack. Don't worry about that standard. We just want to build out the template first. Okay, so it's modifying it now. Yeah, so now, okay, so we can do that. Yeah, and then replace the placeholders in the station template and write the script. All right, that's pretty good. So let's give it the station template. Here is the current station template we have. Here's the current station template we have. Okay. Yeah, so when I generate the bash scripts, this needs to be in TrainTrack. Rather than bash. Okay, so all right, this might be good. So we've got a new Mocker script here. Now that we're using a template, we don't have to have that section, so the Mocker script gets quite a bit shorter. And then the I'll take this. Okay, and this is probably not right. I'll need to check this over with Drew, but let's try running this now, and hopefully we'll get train track code for each of these rather than that. And it's not going to be the real thing, but that's okay. I'll change it later on. Oops, it looks like there's a problem. What I want to happen when mocker.sh is run is that it produces .tt train track files rather than bash files. Can you fix that? Yeah. Okay, so here's the updated Mocker file. All right, and then updated station template. Okay, and then let's see if this works. There we go. So now we've got train track, but it didn't do the names. So or the normalizing the tool names didn't work the same way. Okay, we can get rid of this folder. And then Mocker. Yeah, normalizing the tool names didn't happen the same way, so we can go back to the normalization from before, which was forget where it was. Oh, it was after this. Yep, this is it. All right, so if the file names look good, then we'll commit this because we've got a number of things looking good. So I'll normalize the tool names. So there should be a section talking about that. Yeah, here. So okay. Now it's gonna call it the template file. Oh, that's okay. Okay, so we can just replace this whole statement. Yeah, so we can replace it from here to here. There we go. And then that will normalize the tool name, and then it will add it there. And that should do it. There. Yeah, now the tool names look a lot better. It's just cosmetic, it doesn't matter, but it's nice to have a starting point like this. Okay, so now these are train track templates. So now they'll get fed into a prompt file. So now each of these templates needs to be converted to a prompt file. So it's just the template's going to be added to. I think I already have. Yeah, so it's going to have the prompt, and it's going to have the template, and it's going to convert it. Okay, so this is a good place to make a commit now. So we're gonna get rid of this. I'm gonna say generates TT scripts out of station template for each QA tool on spreadsheet. All right, so let's see what the time is for that. And probably, okay, so we're at the 3 hours. It's not quite an hour, but you know, it's a long video. So yeah, I think that's where I'm gonna stop. And so this will be an ongoing series. This is a brand new playlist, moving on from mathematics for machine learning. I'll definitely, I think, probably get Drew himself on this channel. And we might do, it'd be cool if we could do some live streams in the future, or take some donations for this project too, because this is something Drew's really excited about. He's got decades and decades of experience in computer science, so it's something he's thought a lot about, and that we're building a business around. So I think a lot of people would be really interested in this. So that's it for this video. Thanks for watching, and see you in the next one.